Hello everyone and welcome back to another Universe Sandbox 2 video. Now I know it's been a while, I'm sorry about that, but anyways, today we are going to be turning the moon into a star. So I've never actually seen anyone else do this on YouTube, I don't think, so hopefully this is my idea, no one else has done it. But anyways, without further ado, let's turn the moon into a star. Now I only want to make it into a red dwarf, because if I make it into a star like the sun, it will destroy the Earth. But if I want to make it into a red dwarf like this, so we can see the effects it will have on Earth, then maybe after Earth is pretty much roasted, we'll turn it into a larger star. I don't know, but anyways, first of all, let's do the usual thing, which is colliding stuff into the moon to make the moon larger in size. So let's start off with another moon, I guess. So let's throw a moon into a moon. So let's just place it right there. And let's actually just spam a bunch of moons in. All the original moon is gone. Alright, there we go. Oh, the screen's going all crazy right now. Alright, the moon obviously won't be in the original spot it was when it was orbiting Earth, but it was still near Earth. Earth is only over there, which is pretty good. So there we go. Alright, so now we just want to continually spam tons and tons of moons in till we can put a Mercury or something in. So let's do that. Well, look, all these moons escaping. Wow, they're all going to collide. We better actually drag those in so they don't do that. So let's quickly do that. Just quickly. This is why I like edit mode. So if anything ever escapes, you can literally just pull them back in, which is awesome. Oh, there we go. And now they're all going to collide. Look at all these fragments. Wow, that's pretty crazy. Look at this one here. That's huge. It's a white one as well. Whoa, 6,000 degrees. That is hot. Oh, God. How hot's the moon? 7,800 degrees. All right. Right, can we eat a Mercury yet? All right, we can eat Mercuries. All right. Let's try a Ganymede. Oh, we can eat a Ganymede as well. Okay. So we can eat the largest moon in the solar system now, which is pretty good. Why do they keep on disappearing? Wow. All right. Oh, there we go. So we're going to have a Ganymede escaping. We can't allow that. Let's just delete that one. All right. Wow. This is pretty crazy. And where is the moon? Oh, there it is. Okay, so now we just want to literally just spam loads and loads of Ganymedes around. Wow. Look at them all just merge in. That's cool. All right. Let's throw a bit of Saturn's moon Titan here just to get more elements and stuff, I guess. And now can we have a Venus? Okay, nowhere near eating a Venus yet. Let's throw a few more Mercuries and then just to continue with the Ganymedes. All right. So there we go. Now I'm just literally just going to spam click my mouse. And then we just have to wait for it to get as large as Venus so we can start throwing Venuses. Oh, what about Mars actually? Oh, we can eat Marses, okay. The larger the object is, the more size it gives the moon. That's why I wouldn't just continually put moons into moons. Might as well just put the larger the moon gets, the larger the objects we put in it. Alright. Let's continue, just keep clicking these guys in. A lot of clicking, good finger exercises if you have this game. Try it out, trust me, it's good. Actually does wear your finger out for. But anyways, let's continue with Mars. Now surely we can eat a Venus now, can we? Okay, is it getting bigger still? Look how hot it is as well, it's glowing white. Wait, where's the Earth gone? It's over there right now. How does the moon look? Oh my god, it looks like another star. So if you thought the moon was bright in the sky and look at night, well, look at the moon in the sky now. That's huge. Where's the sun? Can we see the sun? Yeah, there's the sun there. So it looks really bright now since it's obviously larger as well, so it'll be larger in the sky. Alright, let's just quickly do that so it gets bigger. Alright, there we go. Just have to speed up like its thing. Because if I don't press that, if I don't press the radius and composition here, it will take forever to get to this size. So if you just do that, it will skip the time and it will just go straight to how big it should be. So that's all good. Alright. So it looks like we're getting a little further away from Earth as well. Right, let's hit play again. Let's make sure it's in orbit of Earth. So let's quickly press auto orbit there. Alright, so now it should be in orbit of Earth. So now let's start throwing Venuses in it. Wait, can we hit planet 9 yet? Okay, we know we're having a planet 9, so... where's Venus? There it is. We can throw Earths in as well, so now our moon can have water on it. There we go. Come on, we'll get back in there. There we go. It's really one of the best episodes I've done. This is the first one I've done on the latest update for Universe Sandbox as well. All of my previous videos, apart from obviously the Alpha 19.5 review, they were all on older builds of the game. So this is the latest version of the game, which is pretty sweet. So things are running better from what I've seen already, which is pretty good. So there we go. Now I think also for the next episode of turning something into a star, this is just like a special, I guess, but it will be Saturn, because Saturn has actually received the most votes from all the comments, I believe. So yeah, we'll be turning Saturn into a star next. Come on, I really want you guys to vote Mercury, because I really want to see what happens to like the inner planets when we do that. Please vote Mercury soon. In my next episode, when I ask, please vote Mercury. Yeah, I really, really want to do Mercury. But honestly, it's up to you guys, so I just have to wait and see, I guess. Because eventually I'll get around to doing it, because there's only so many planets we can turn into a star anyway. But anyways, that's getting pretty large now. We're eating up tons of Earths. Oh, Earth's getting really far away now. Yeah, we're definitely getting further away from Earth. Maybe if we try and put Earths this side, maybe the moon will travel towards them. I don't know. Yeah, we're pulling the moon inwards. I think we're like, the moon is travelling towards these Earths, which is pretty good. Look, all the Earths just combine into one large one. That's cool. Let's throw a few more Venuses in there as well. Right, can we eat any of the Kepler planets? Oh, yes, we can. Perfect. Let's try some of these guys as well. Let's just spam all of them. I still can't remember which one's the largest. Wait, let's have a look. 10,000, 8,000, 10,000, 9,000. Oh, okay, so it's this one. Oh, not this one. Not Kepler 10b. It's... Wait, is it? Oh, it's Kepler 69c. This is the largest one out of them. Wait, what about Kepler 22b? Let's see if I can find that. Oops. Kepler 22b. Oh, there we go. Oh, no, we can't even eat that guy yet. Yeah, one of the larger... Or we think it's a water planet. We can't even eat this thing yet. This thing is massive. Alright, let's continue to spam these guys in. What about this one here? This is a custom object of mine, which I custom made. But it's still apparently got water on it, according to what the game said, so... Yeah, I spawned, like, the game's version of that object in that had water on it, so I kind of made my own custom version, so... Yeah, deal with it. But, anyways... Wow, look at all the objects this is eating, wow. Look how large it's getting. Can we just do that? There we go. Right, and we should be able to eat gas giants soon. Wait, not Uranus yet. No Planet 9. What about a random gas giant? Can we eat those? No, we're not eating them yet. Alright, we have to continually spam some rocky planets in. In fact, actually, let's cheat. Actually, let's go to 20,000 kilometers. There we go. Oh, that's not even large enough still. Wait. Oh, let's just go 25,000. Just a few things out. You don't want to see me doing the same thing all the time. Alright, so we can now eat Neptune and we can eat Planet 9s. Wait. Can't eat a Uranus next. Uranus is still a little bigger. Wow, look at all those explosions. That's cool. Wow, look at that. That's cool. Alright, anyways. Let's throw a few Planet 9s in, and now let's throw the good stuff. So, Neptune. My favourite planet, Neptune. Love Neptune. Just look at it. That blue is so nice. Yeah, I like it for its colour, and because it's like, in my opinion, it's like the most mysterious out of all the planets. Just because it's the furthest known planet, because we don't actually know if Planet 9 exists yet, since it's still just a theory, but... Yeah, Neptune is so interesting due to its fast winds and its moon Triton. Like, its moon Triton will eventually get too close and get torn apart, and then it'll make Neptune have a new ring system. Because if you didn't know, Saturn will actually lose its rings. So while Saturn loses its rings, Neptune will gain rings. So, yeah, that would be pretty cool. But sadly, we won't be around in like 100 million years. So we'll never see that happen. Unless you're like invincible, you can never die, which would be kind of cool. Please tell me how you're doing that. But anyways, okay, we're not only eating a Saturn yet. Right, Uranus. There we go. We can eat plenty of those guys. What about Gliese? What happened? Wait, did it disappear? Where'd it go? Wait, what? Oh, Uranus! No! Uranus destroyed the moon. Okay, that's not right, because Uranus should have been destroyed. Dang it, Uranus, why do I have to do this? And I am pronouncing it right. I'm not saying your anus, it's Uranus. Alright. We have to get another moon in and cheat it back up to size. See, that makes sense. How did the moon just randomly disappear there? Alright, let's do that. Let's just go to 30,000. Yeah, get out of here, Uranus. We don't want you here. There we go. Now prepare to get eaten by our moon. Our super moon. Ah, the moon's now a gas giant. Can't eat it. Get rid of that disgusting planet. There we go. Yeah, I still have to say Uranus is probably the most boring planet, not just because of its name. No, that's nothing to do with the name at all, actually. But yeah, because it's the least interesting to look at. Because if you've seen a picture of a real-life Uranus, like what it looks like in real life, it is just a very, like, bland colour. Like, it's all one colour. It doesn't look, like, nice at all. See, the one in the game, it doesn't look like this in real life. It's a lot more the same colour. It's just a very, very light blue. And it just... Like, it just looks so boring. It's also the most coldest planet, and we know the least about it. Like, we know more about all the other planets, but Uranus, I believe, we know the least about. Come on, where's the Earth? Is Earth anywhere nearby? Where is Earth? Wait, let's check the labels. Oh, there it is. It's over there. Let's get a little closer to Earth again, because we don't want to get too far away. So let's move back into Earth. There it is. Look how large it's getting now. Oh, poor little Earth there. Alright, let's remove these fragments as well. So let's just do that. Wait, Control F. What key do you press? Control D. Okay, I don't know why these fragments aren't disappearing. That's kind of annoying, but I just have to live there. There used to be a command where you could hit Control D and it would remove the fragments, but I don't know why that's not here anymore. Alright, so how large are we at now? Can I just do that? Okay, we're getting a little smaller. I don't know why I did that. Alright, so can we eat a Saturn now? Okay, we still can't eat a Saturn. That sucks. Alright, let's continually eat Neptune's, I think, because Neptune has more mass. Oh, it happened again! Why did the moon disappear? Okay, that didn't happen. Pretend that didn't happen. Alright, let's just go straight up to 60,000 now. There we go. And it happened again! Why did that happen? Oh, do you know what? I think it's because Neptune here has more mass. Even though the moon is larger, Neptune still has more mass. So, yeah, that's probably why. So, let's just go to the mass quickly. And let's turn this to 100 Jupiters. There we go. We got a star. But, yeah, pretend none of that happened. So, now we have a nice new star. So, let's go to about 1,000. No, not 1,000. It's about red dwarfs are around 2,500 degrees. Right, and now we want Earth to orbit the star. So, yeah, this was what happened if the moon became a star, guys. So, as you can see... Oh, it's pretty... Well, look at the glow, the orange glow. That's pretty creepy, actually. Look at that. That's pretty crazy. Alright, let's make the star a little brighter. So, let's make it about, yeah, 11% the brightness of the sun. So, there we go. Still very dark, though. Alright. Oh, wow. Look how dark it is on this side of Earth. That's pretty cool, actually. It's not meant to be doing that. But there we go. So Earth is pretty much probably going to get roasted any second now. And I'm guessing the whole other, or the rest of the solar system will also get corrupted from this. As you can see, it's already mucked up with the sun. Now the sun will go around it as it goes around the sun. So the sun and the moon are now in a binary orbit. That's kind of weird saying. Never thought the moon would be, like, be powerful enough to control the sun's movement. But I guess that's that, I guess. Alright, so... Now, let's see what happens first. So I'm guessing its temperature's going to heat up. Okay, yeah. Oh god, Earth is getting roasted. So if you live on Earth, you are very dead now. So sorry about that. The moon is quite large. So, there, that's pretty crazy. So, the sun is pretty much tiny in the sky. So let's see how large it is from the surface of Earth. So where is it? Yeah, that's pretty big. So, look what I've done to the moon, guys. Are you proud of me? I've just eliminated all life on Earth, probably, by doing this. Unless there's some bacteria which can survive 2,000 degrees. Well, yeah, 2,000 degrees. So, now, obviously, like I said at the start of the video, we will now, after we've seen the effects of Earth, we'll now make it a little larger. So, goodbye, Earth. Nice knowing you. It's about to fall in any second now. Is it going to... Come on, moon, get bigger. Hurry up. Yeah, Earth is definitely gonna regret seeing this happen, but... Alright. The moon's getting bigger, oh no! And kaboom! And that explosion made the moon a blue star. That's pretty cool. How bright is it? And if it's a blue star, it'll probably be a little brighter. So let's make it one luminosity of the sun. So now this is emitting as much energy as our sun does. Look at the impact mark. That's crazy. Right, so the moon has just taken a humongous smash. Oh, look at all these like comets, or these fragments from earlier, just colliding in with the moon as well. They're like little comets. Look how small it is. Poor little thing. I'm surprised it's not got destroyed yet from being how close it is to the moon. Alright, so now the Earth is gone. Let's see what will happen to the other planets. So obviously, if you didn't know, Venus is the closest planet to Earth. So let's see what's happening here. Wow, it is red here. Or orange, I should say. Oh, it's getting hotter at Venus as well. So the brightness of the moon is affecting Venus, because I believe Venus is closer to the moon than the sun is. Yes, it is. Look what it's doing to the solar system. Oh my god, that's crazy. So, pretty much all of the outer objects are just going to get ejected. So, if you haven't seen my previous episode, the usual stuff is pretty much happening right now. So, Sedna, Planet 9, they've lost their orbits. Now, all of the outer ones have gone crazy, and pretty much all of the inner ones are just getting all corrupted. So it's always from about Saturn or Uranus onwards, all of the orbits just go completely berserk. And Venus looks pretty far away right now. Whoa, where did the moon go? Okay, so it's got 2 stars in the sky. Look how orange it is here. That's crazy. That's a lighting glitch. If I reload this simulation, it will go to a different colour. So let's make it so how it should be. It shouldn't be orange like that. So let's just save that. Let's quickly go to, yeah, here we go. Right, it's reloading. Alright, so if we go to Venus now, it should be a little more, it should look a little more blue. Yeah, there we go. That's how it should look like. Because the moon's a blue star, it's not red anymore. Alright, Venus is still heating up. So let's see what it looks like if we have 2 stars in the sky at once. So let's go to the North Pole of Venus here. So now on the surface. So there's the sun, and there is the moon. Yeah, look how large the moon is now. That's definitely the largest moon in the solar system now, eh? Well, it's not even a moon anymore, it's a star. That's a pretty cool sunrise, actually. Look at that. Binary orbit sunrise. That's pretty nice. Wait, can we take off the surface? There we go. Alright, so we've got 2 binary stars. That's pretty nice. Alright, so let's leave Venus. And now, let's see what will happen to the rest of the solar system. So, Venus is probably going to get hot there. Yeah, I knew it. Or is it going to collide with the moon there? Wait. Is it? Oh, it's going to get close. Its orbit's definitely going to change after this. Look how close it's going to get. Oh, very bright here now. Alright. Oh, that's crazy. Just look at this. Is this even a solar system anymore? It literally just looks like... This is probably what the centre of the Milky Way is like. Because if you didn't know, there's a black hole in the centre called Sagittarius A. And as you know, the Milky Way's got a lot of stars. But the closer you are to the centre black hole, the faster you go around the the Milky Way. So, you know, like, Mercury's the closest planet to the sun, so it goes faster. So the closest stars to the black hole in the centre will go the fastest. Now, I'm guessing there's probably a lot of stars there, so I better reckon they always, like, muck each other's orbits up like this. The orbits are never stable. They always change. A lot of stars probably get ejected from the centre of the Milky Way. And that's what's a high-velocity star's called. So if you've never heard of it, it's basically a star which is going over the speed of light. So it can either get, like, gravitational boosts and black holes and or other stars, actually. And they, like, slingshot across the Milky Way faster than the speed of light, which is pretty crazy. But anyways, yeah, imagine if one of these stars was the black hole, and then, like, all of the other planets were stars, and all the orbits are continually changing and stuff. In fact, maybe I should make a video on that about the Milky Way. That'd be pretty cool, actually. Maybe I'll make it after I've made this one. I have no idea. But anyways, the solar system doesn't look like it's changing that much. Like, if all the orbits keep on disappearing, then reappearing, they just keep on changing. They're not really... Yeah, we've got to speed up time and see what happens. Whoa. Yeah, I want to zoom out from that. It's a little crazy in here. Look at the sun there. Oh, God. Yeah, so it doesn't like the sun or the moon. They'll never heat each other, because they're always at opposite ends of, like, their thing, I guess. They're both going around. It's just so cool how this works. Like, the sun, it may look like it's moving, but it is actually going around this circle. So if I literally just move, now we'll see the sun will move, because I'm not locked onto the sun anymore. So we'll see, like, they are moving. They're going in this direction, this way. Look at this. This is literally nuts. Oh my God. Look at this. The binary orbits are just crazy. Wait, where's Mercury gone? Wait, is that there? Wait, what was this? That's a fragment. Wait, where's Mercury? Oh, here it is. Well, Mercury's got, like, flown out the inner solar system as well, and that's further away than Mars is. Wait, where's Venus as well? Wait, Venus? Oh, we've lost Venus completely. Venus has gone. Venus has been completely ejected from the solar system. That's not good. Its atmosphere still shows it's getting light, but if we just turn that off, so it's hidden... Oh, no, it is still getting light. Oh, okay. I thought it would be in complete darkness, but okay, there we go. So Venus is just now very cold. It's now one of the coldest planets in the solar system, so there we go. How's Mars doing? Good old Mars, the red planet. Even though it's pretty much pink. Ooh, quite bright here. Oh, 116. So now Mars is probably the hottest planet. Where's good old Jupiter? We haven't seen Jupiter today either. Where's Jupiter? Is it somewhere? I know it's here. There it is. Still minus 150. So, yeah, the outer solar system isn't really changing much. Yeah, there's the orbits, so how they've affected or changed. So, yeah, as you see here, Venus just got completely slung out over here. Mercury... Wait, where did Mercury go? Oh, there's Mercury there. So Mercury's got a very bizarre orbit. So it goes in and out all the time. So that could get thrown out the solar system eventually as well. So that kind of sucks for Mercury, I guess. Alright. So I think that should pretty much end this episode off, because, like, nothing else is really going to happen. Like, it's just the same old stuff. Like, if you've seen like all the previous videos where I've turned like some of the planets into stars, stuff eventually gets thrown out. But it's just cool to see the different like possibilities if a different object was turned to a star. Because obviously the sun just gets like locked in a binary orbit with the new star, and then the new star just causes havoc for the whole solar system. So this is why there's not many like. So if you've heard, like, most, like, habitable planets we think we've found, like the Kepler planets, or, like, any planet we think has water on it, which could have, like, oxygen and life, they're always in, like, red dwarf solar systems, because loads of other star systems, they always have more than one star, and then when there's more than one star, stuff like this happens. So any planet would continually, its orbit would continually change, so it wouldn't be able to support life if it continually went hot, cold. So yeah, most planets we found, I believe, are in single star systems. Not just red dwarfs as well. Obviously, there's some yellow dwarfs and all that stuff. Maybe blue. I don't know about blue stars, actually. Because blue stars are dangerous. They release more, like, radiation and, like, gamma waves and stuff, I believe. I don't know what type of radiation it is, but yeah, I know they're pretty dangerous. And obviously, they're a lot brighter in the sky. Like, if you think the sun, it's bad looking at the sun in the daytime, try looking at a blue star. If the sun was a blue star, like, it'd be very bright. It would definitely kill your eyes a lot quicker than the sun would if you looked at it for too long. Anyways, yeah, see, as you can see, I'm speeding up time quite a lot. Nothing is really happening. The orbits are just going crazy, but all the planets are still hanging in there. Wait, that's just a dwarf planet. Okay. Yeah, so like I said, that will end off this episode here, I think. So, yeah, hopefully you all enjoyed. Leave a like, subscribe if you're new, and yeah, I guess so. Yeah, tell me what planet I should do after Saturn, because Saturn will be the next planet I turn into a star. So please pick Mercury. But yeah, tell me what I should turn into a star next. So if you haven't seen the previous episodes, make sure you go check them out as well. They'll be in like